Video number 68, determining if a function is one-to-one. Let's go over a couple definitions. The definition of a function, if you remember, is a relation where for each input, there's exactly one output. Okay? Now we're going to talk about a specific type of function. This function is called one-to-one. A function where each output comes from one input, or exactly one input, if you want to put that in. So now we're going to say, okay, is the function one-to-one? Is f of x one-to-one? Well, if we believe that the function is one-to-one, then we must show that if f of a equals f of b, then a equals b. In other words, if these two outputs are the same, the only way that would happen is if the inputs were exactly the same. Okay? In other words, we're going to say, okay, let's say these two outputs are the same and they're different. The inputs were different. Let's just say A and B are possibly different. All right? Well, if we can come to the conclusion that A and B are not different, then we have not then shown that the function is one-to-one. So we're going to start off by saying, okay, let's assume f of A equals f of B. Well, now you're going to have a cubed plus 5, because you just plug an a in here. A cubed plus 5 equals b cubed plus 5. Well, then you subtract 5 on both sides, do the cube root of both sides, and of course you get a equals b. Therefore, f of x is one-to-one. If the outputs are the same, the inputs must be the same. That's why this is one-to-one. Now we take a look here at g of x equals x squared minus 4. Well, if we believe that the function is not one-to-one, then we must show that two different inputs, okay, we must show that two different inputs give us the same output. And this is going to happen when you have a squared, because what do we know about x squared? Squaring turns negatives to positives. So g of 3 gives us 9 minus 4, which is 5, and g of negative 3 gives us 9 minus 4, which is 5. So therefore, we have two different inputs giving us the same output. Therefore, g of x is not one-to-one. Okay? So let's take a look at these two. We have an absolute value, and we have a linear equation. Well, the absolute value, what do we know about absolute values? It turns negatives to positives. So think about this. What is h of 1? What is h of 1? Well, that's going to end up being 1 plus 5, which is 6, and the absolute value of 6 is 6. Well, is there another way to get 6 in here? Well, yeah, you could have a negative 6. That would mean you'd have to have negative 11. Isn't h of negative 11 also equal to positive 6? Yes, therefore, we can say that h of x is not one-to-one, because these two outputs came from different inputs. Okay? Now, what about a linear equation? Well, a linear equation, you're only going to get one output for each input. It's not like any of the negatives turn positive or anything like that. So let's go ahead and try to show that what? If k of A equals k of B, then we are hoping to arrive at the conclusion that A equals B. So let's see if that happens. Well, you're going to get what? Negative 3a minus 10 equals negative 3b minus 10. Then you're going to add 10 to both sides and get negative 3a equals negative 3b. Divide both sides by negative 3 and a equals b. Therefore, we can say that k of x is one-to-one. All right? Any questions or concerns? Please do send me an email, and of course, good times.